Hello everyone, let's factor. Let's kind of wrap up the ideas from all of the things we've learned in Algebra 1 about factoring and sort of review those things real quick. So try and give you some strategy here. How you're going to factor really depends on how many terms there are. Now, the exception to that is you are always, no matter what type of factoring you're going to do, you're going to look for a greatest common factor. So the first step is always decide, do all the terms in the polynomial have something in common? And if they do, factor that out. So that's the greatest common factor. Then you're going to have a choice depending on how many terms there are. If there are two terms, right now, the main thing we're looking for is a difference of two squares. That's the a squared minus b squared, which factors into a plus b, a minus b. Okay, so first thing, if you have two terms and you've done GCF, look to see if they're both perfect squares. If they're not, then you're done. If you have three terms, then you're going to look to see if you can split the middle. Okay, and that essentially means we're taking the three terms and we're converting it into four terms, and four terms is called factor by grouping. So factor by grouping is how we end three terms and four terms. When we split the middle, we take the three terms, we make them four terms, and then we factor by grouping. So factor by grouping, we're going to see an example of all these here in a second. Okay, so the first thing you need to do is look and say you have 1, 2, 3 terms. So if there's three terms, you're always going to look for GCF. Okay, first we're going to look for a GCF, and then we should try and split the middle. Now, we have to first do the GCF, and then we'll take our three terms and try and split the middle. So 12, 22, and 70. Let's see, what are those all multiples of? They're all multiples of 2, and they all have an x. So let's try 2x and see if that's the greatest common factor. 2 times 6 gives you 12, and you need 2 more x's, plus 2 times 11 gives you 22, and you need 1 more x. And 2 times 35 gives you 70, and that's the only x you need. Now we've got 6, 11, and 35. Do those have anything in common? Okay, to decide if you're finished, you need to look at those and say, do those have anything in common? 6, 11, and 35? I don't think so. 11's prime, so unless it goes into the other numbers, I think we're pretty much done. But now we're going to try and split the middle, and since this is a pretty big number, I'm going to make a table. I'm going to figure out what numbers multiply to, and I need my calculator, so I'll get my calculator out. 6 times 35. 6 times 35 is 210. So we got to find multiples of 210. It's going to actually be negative 210, so we'll place a 0 somewhere that add to positive 11. Now, you can just take your calculator and you can just start dividing. Now, I don't think I need to divide by 1. That's 1 times 210. 2 times 105. Okay, and if you're not sure how I'm getting that, just take 210 and divide by 2. All right, 210 divided by 3. 3 and 70. All right, 3 times 70. 210 divided by 4. I don't think that's going to be nice. Nope. 210 divided by 5. 5 and 42. 5 and 42. 210 divided by 6. 6 and 35. I'm going to have to make one of these negative, but I'll come back to that. 210 divided by 7. There's a lot of factors. 7 and 30. We're going to have to keep going. 210 divided by 8. 210 divided by 9. 210 divided by 10. Oh, I think I got it. 10 and 21. 10 and 21. So I'm going to stop. I can keep going and probably find a couple more, but I'm going to stop there because I can make this negative and then those add to 11. They multiply to negative 210 and they add to positive 11. So I'm going to split the middle. 6x squared minus 10x plus 21x minus 35. I'm ignoring this 2x for right now. I'm just factoring the part in black, and it's split the middle because I took that middle term 11. I'll kind of square it up a little bit. I took that middle term at 11. I split it into two terms that add to 11, but I had to make sure that they also multiply to negative 210. Otherwise, this doesn't work. Now, once I have four terms, I'm factoring by grouping. So the GCF of the first half, these are both even, and they both have an x. 3x minus 5, so that's 6x squared minus 10x. That looks good. Bring down the plus sign. 21 and 35 are both multiples of 7. 3x minus 5, so that's 21x minus 35. And if you notice, hey, we got 3x minus 5. So one of my factors is 3x minus 5. The other is 2x plus 7. And then I ignored this at the beginning, but my GCF is 2x, so make sure you write that as part of your factors. Now I am completely factored. So I started with GCF, and since there were 3 terms, I did split the middle. This problem has 2 terms. So again, we're always looking for GCF, and then we'll look for dots. So is it a difference of 2 squares? 4 and 36 are both multiples of 4. So I'll factor out the 4, and then I can look, wait, x squared is a perfect square, and 9 is a perfect square. The square root of x squared is x. The square root of 9 is 3. So it's x plus 3 and x minus 3. And remember, the GCF is 4, so bring down the GCF. Okay, so that was much faster because it's difference of squares. You just got to know the square roots. 1, 2, 3, 4. This term has 4 terms. So first I will look for GCF, and then I will factor by grouping. So we'll factor by grouping. And let's see, 27, 3, 45, and 5. Is there anything that goes into all of those? Again, 3 is prime and 5 are prime if you're not going to find a big GCF. So there is no big GCF. Okay, let's find the GCF of the first 2 then. That would be 3x squared, and 3 times 9 gives you 27. I have 2 of the x's, but I need another x. Minus 3x squared times what gives you 3x squared? 1. That's a placeholder 1. Be very careful there. Plus, bring down the plus. 5 and 45 are both multiples of 5. And 5 times what gives you 45? That'd be 9x. 5 times what gives you negative 5? Negative 1. So again, we factored out the entire thing. You need that placeholder. But it works. We have 9x minus 1 for one of our factors, and the other is 3x squared plus 5. And you can look, but those aren't perfect squares, so we are finished at that point. It's not a trinomial, and it's not a difference of perfect squares. All right, what would make this one factorable? So this kind of goes back to the idea I was working with here where I was making a table. So, geez, every time. I'm going to do the same thing. I'm going to multiply a times c. I need numbers that multiply to negative 45, and I'm just going to say they add up to whatever the b value is. So if I make a table for 45, I'm actually going to show you how to do this on your fancy science graphing calculator if you got one. So watch this. If you want to make a table for negative 45, just do negative 45. I'll go back to the beginning. Go to y equals right here. Okay, this is where you can make a table. Negative 45 divided by x. Oops, that didn't work. Negative 45 divided by x. Instead of me doing negative 45 divided by 1, divided by 2, divided by 3, divided by 4, I can just do this, and then I can go to the table. See how it's blue? So hit the blue button, then hit table, and these are all numbers that multiply to negative 45. I wonder if I can make that bigger. View large display. Okay, so I'll just start screenshotting. I got that, okay, and I'll paste those here so I can keep looking at it. And then if I go back and I can scroll down, and I'll look for a repeat. Once I get a repeat, I know I can stop. 3 and 15, is that a repeat? Yeah, I think oh yeah, I already had it. I didn't even need to go that far to find a repeat. It's 5 and 9, so I've got everything here. Okay, you start to see repeats at 5 and negative 9. That happens again right here, so I'm done. Those are the last options. It could be this, or it could be that. It's either 1 and 45, or it's 9 and 5, or wait, where's 15? Oh yeah, 3 and 15. 3 and 15. So it's got to be one of those. So if I have 1 and 45, 3 and 15, and 5 and 9, the numbers that I could make for B, one of them's got to be negative, would be 45 minus 1, so 44, or you could put the minus sign there, so we'll say plus or minus 44. It could be positive or negative. If you put the negative right here, it'd be 15 minus 3, so 12, but you could also put the negative right there and make it negative 12, or 9 minus 5 is 4, so plus or minus positive 4. If you put the negative there, it'd be negative 4. I could split the middle with any of these numbers right there. If this was positive 4, I would use positive 9 and negative 5. If it was negative 4, I would use negative 9 and positive 5. But those are all the numbers that would make this factorable. And if I put any other number there, then I can't do it. Okay? You can't factor it if the b value is not plus or minus 44, plus or minus 12, or plus or minus 4, because these are the only numbers that multiply to 45. So you won't be able to find something if they don't do both things. Okay, let's do one more. This says find a dimension, so this is sort of like an area problem, but it's got 3 dimensions, so we're saying it's volume. Well, there's 3 terms. If there's 3 terms, I need to start off with, oh yeah, GCF, first GCF. So 15, 35, and 5, those are all, or 20, those are all multiples of 5. X, 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 they all have 1 X. 5 times 3 gives you 15, you need 2 more X's. 5 times 7 gives you 35, and 5 times 4 gives you 20. So I got 5x as a GCF. Now I need to factor that. So to factor that, I will find numbers that multiply to 12 and add to 7. Well, 12 is either 1 and 12, 2 and 6, or 3 and 4. The ones that add to 7 are 3 and 4. So I will split the middle, 3x squared. Now it's plus 3x plus 4x, and the 4 doesn't change. So I just split the middle. I'm ignoring the 5x for now. The GCF of the first two is 3x, and you have x plus 1. Bring down the plus sign. The GCF of those two is 4, and you have x plus 1. So now I have x plus 1, 3x plus 4, and then don't forget now my 5x is my third factor. That is the factored form. So if you want to talk about volume, I could say, like, let's call this it doesn't matter which one is which. Let's call that 5x, the length. This is x plus 1, the width. And then this is 3x plus 4, the height. It doesn't matter which one you make. They're interchangeable, okay? But then, sort of as like a bonus, it says, what if the dimensions were, if x was 5? So I could plug in 5 right there. 5 times 5 would be 25. 5 plus 1 would be 6. And 3 times 5 is 15, plus 4 would give you 19. So maybe it's like the length, width, and height. If you wanted to find the volume, you could then multiply those together. I don't like this. View, hide, large display. So to find the volume, you would do length times width times height, which is 25 times 6 times 19, and you get 2850. The way you can check this, if you did all of that right, plug in 5 right here. 15 times 5 cubed plus 35 times 5 squared plus 20 times 5. And if I get 2,850, I know I had the factored form right, and I got the volume right. Sweet, 2,850. I know I did it right, okay? So you can do that with any factoring. If you just pick an x and kind of go back and plug it in to see if it works, it will work. If you pick an x right here and you plug it in and you get the same thing right here, you know you did it right, okay? That's sort of a crash course in factoring. You need to make sure you practice all of this. You need to be absolute rock stars at factoring, and also you should smash that like button.